all decide to ride the Ferris wheel. When the last seat is filled and the Ferris wheel starts, your seat is at the 3 o'clock position. Let T be the number of minutes that have elapsed since the Ferris wheel started. At the top of the wheel, you are 85 feet above the ground. The wheel makes a revolution every 6 minutes. The diameter of the wheel is 80 feet. Okay, so who could tell me, what do we know? Yeah, Catherine. Okay, the maximum height is 85. Remember, this is height. Okay, what else, Jax? Huh? The minimum would be 5. Why? Good. Good. So the diameter is 80 feet, right? And if the maximum is 85, the max minus the diameter gives you the min. So 85 minus 80 gives you the 5 feet for the minimum. Okay? What is the, what else? Tell me what else. Yeah, Catherine. The amplitude is 40. How do you get that? Good. Okay. Midline. Yep. Okay. 80 divided by 2 gives you the amplitude of 40. Okay. You gave us a whole bunch of information there, right? So if the amplitude is 40, can't we, for the midline, 40 plus 5. You cannot forget this 5 here. Or 85 minus the 40 as well. Okay, to find your midline, which is 45. Okay? All right, and to find your midline, I'm just jotting down some information. 40 plus 5, shoot the 45. Okay, what else do we know? Or the max minus amplitude. Yeah, Kip. Okay. Any, yep. Good. So our period, and I'll add this all here too. The period is 6 minutes. Okay. Period is 6 minutes. So anytime we are given the period, we have to do what to find the increments? Find the scale. How do we find the x scale? Yeah, Grant. Divide the period by 4, and what do we get? 1.5. So 5, 3, 4.5. All right, so the maximum point, I'm just jotting it down again. Amplitude was 40, vertical shift 45 feet. Okay, so since we're starting at the 3 o'clock position, what graph do we have? Sine or cosine? Sine. So we're starting 3 o'clock position, okay? And where do we go? Up or down? Up. Good. Good. Okay, if you wanted to draw a picture with a circle, some of you did, okay, drawing the Ferris wheel, you can show that we're 5 feet above the ground, the maximum is 85, do the halfway point, and knowing that it's going counterclockwise. So, how do we come up with our equation? How do we come up with our equation? Well, first, let's always begin with y equals, okay, what is our amplitude? 40, so that's our A value, right? And then we're using sine, Okay, we'll fill out B in a second. What is our midline? Plus 45. We're up on that midline. All right. So we know the period is 6 minutes. Okay? So remember the period formula, 2 pi over b. We need to find that b value. So 6 equals 2 pi over b. Okay? B equals 2 pi over 6, which reduces to what? Pi over 3. Okay? So we have pi over 3. Let me just fix. Okay, good. Okay, so that is your equation. Typically, your b value, if you're in minutes for real world scenarios, your b value is going to have that pi. Okay? And when we get to h eventually, if you're going to input this, you will have to make sure your calculator is in what? Radians. Good. Okay. How much time will it take to reach the lowest point of the Ferris wheel? 4.5 minutes. Okay. So from the midline to the lowest point is 4.5 minutes. Okay. And that's your minimum. Use your equation to predict the height above the ground when t equals 6, which we could also see from our graph. What do we have? 45 feet. Thank you, Catherine. And then 9 we can't see on the graph, but can we predict it? What would it be? 45 as well, right? Okay. So before we continue, a Ferris wheel problem is what you typically would see as an example, okay? There will not be a word problem on the final, but you will have one on your test. Okay, you'll actually have two, one Ferris wheel, one tide. Okay, and the tide problem that we're going to do in a little bit will not be the one you will see. You will see like the first or second one we did last class. Okay, very straightforward, very easy, very basic. Because you'll do more of this, those of you continuing to pre-calc will. Okay, so as you go through, and I just want to raise a hand. How many of you can figure out the minimum? Okay. How many of you can figure out the midline? Some of you had 40 at first. Do we understand why it's 45? Okay, just want to make sure. Good. Now, how can we tell with this, what was some key information to determine if we are using sine or cosine? Yeah, Catherine. Yep. And that's going to be the difference between sine and cosine, okay, in terms of the Ferris wheel. You want to determine where you're starting. Yeah.
So what would it say for cosine?
If it was cosine, for the Ferris wheel, it would either start from a platform of the lowest point, which typically you won't see. It would be up above a little bit, okay? Cosine will pretty much be your tide graphs, okay? Do we understand how to find, identify the period and then the increments? Are we okay there? Yep, good. Okay. Finding your equation. Understanding the A value. Are we good? Okay. Understanding the D value, which is your midline. Yes. Finding the B value. Okay. If you need to, you could rewrite and say, if I need to find the B value, it's 2 pi over the period. Okay, that's your other equation you could use, which you end up finding anyway. Okay. Any questions about number 1? Yep. Yes. Yep, go ahead. Then it wouldn't be a diameter. It would give you something different. Yeah. From the max. So here, if you were to, and you guys can answer this, say if you were not given the diameter, okay? And I think Catherine mentioned it before. If you were not given a diameter and had to find the amplitude or the midline, what would you do? Yep. So, and what would that be? Good. So to find the midline, you would add the max and the min and divide by 2. And then the difference would be the amplitude. So 85 plus 5 is 90, right? Divide by 2 is 45. That is your midline. And then 45 minus 5 is 40, which is your amplitude. Okay? You're welcome. All great questions. Great questions. Yep.
For H, if you were to be given a time that isn't on the scale, you would put it into your calculator.
For X,
Okay.
though. Okay? So great point is, so if you were given, and that's actually, we saw that last time. If you were given like T equals 5, right? And you can't really see it on the graph, you would plug 5 into X. Okay? If you can't see it on the graph, you will plug 5 in for X. Okay? If you wanted to know the height, that is, let's say, 50. Okay, we did this last class. If you wanted to find the height, when are you at 50 feet? Okay, you would have this as y1 and 50 as y2 to then see the intersection. Okay, so that is another tool you could use. Okay, but most cases you're going to see everything you need on the graph. Okay, yep. Yep. Yeah. Yep. And again, we tried it a variety of different ways. You could either, if it's t equals 5, this would be 5 pi over 3. You could do that as well because it's 5 over 1 times 5 over 3. Okay. All right. So when we get to graphing for 2a, what is the amplitude? 1. Okay. The amplitude is 1. What is the period? Pi over 2. So we have 2 pi over 4, which is pi over 2. So I know I am ending at pi over 2. My amplitude is 1, negative 1. What is my x scale? Pi over 8, because it's pi over 4 pi over 2 divided by 4. So it's pi over 8. What comes after pi over 8? Pi over 4. Then what? And then we end up with pi over 2. Okay? Does everyone see that and understand it? Okay? Okay. Where do we start this graph? What value? Eliza? The max one. Good. 1. Then we're at 8. Negative 1. Okay. Good. All right. For B, what is our amplitude? A half. Good. What's the period? 2 pi. X scale. Pi over 2, which is very similar to what we've been seeing. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay. What is our midline? -2. Okay, what would be the maximum value that we have? Grant? -1.5. Excellent. What would be the lowest point we have? Yep, Jaden. -2.5. Okay, where does the sine function start? -2. Then where do we go? Up, good. And then back to your midline. Okay, that's your F. Okay, and for the last one, what is our amplitude? 1, but what's the deal? What's happening? It's reflected because it's negative. Okay, what is the period? 2 pi, x goes pi over 2. Okay. Okay, what is my midline? -2. What is my highest value? Lowest? Okay. Now this graph, where am I starting? -1, -2, -3. Where? -3. Here's your midline. Okay, here's your midline. Cosine normally starts at the maximum value, which is -1. But since there's a reflection, you're at -3. Here, here. Okay, yeah, yes. Okay, what is my domain for all these functions? Yeah. -infinity to infinity. The range would be in brackets from your negative, your minimum, to your maximum in brackets. Okay? Any questions about graphing? Okay. All right. So this one is a different type of question in terms of tides. I wanted to show you to give you an idea of how it's different. Okay? Throughout the day, the depth of the water at the end of the pier varies with the tides. High tide occurs at 4 a.m. Okay? So high tide occurs at 4 a.m. with a depth of 28 feet. So right there is our what? Maximum. So max is 28 feet, and that is at 4 a.m. Okay? Low tide occurs at 8 a.m. with a depth of 16 feet. What is that? Minimum. Okay. Okay. All right. So, what is the difference? What is the time difference between your max and min? Yeah. 4 hours. Okay. So, can we determine, because they don't really tell us the period. They tell us model the problem by using a sinusoidal equation, which is sine or cosine, to show the depth of the water t hours after midnight. Okay, showing all your work. First sketch, then find an equation. So they're saying right now that we should start, this should be 12 a.m. at 0. Okay, so how can we work? How can we figure out the period? How can we figure out the amplitude? How can we figure out the midline? Okay, I want you to think for a minute. Okay, I want you to think they're not telling you what the period is. Okay, they're not telling you. All they're telling you is you're starting at 12 a.m. That equals 0. Okay? They're not telling you. They gave you the max and they gave you the min. Okay? I want you to think for a second. Think for a second. And I want you to think how many hours it would be max to the next max. Be careful. Just 4-hour difference. Hold on. Easiest part for you to figure out. What was the first thing you figured out? A lot of you did. David, the midline. How did you figure out the midline? Okay, so you added these guys, right? Okay, 28 plus 16, what did you get? Okay, divide by 2, right? And what's our midline? 22, okay? So our midline is 22, okay? Therefore, amplitude is what? 6, okay? So midline, 2, and the amplitude is the distance, which is 6, okay? Is the distance from the max minus the midline. All right, what else? What's next? The period? Yeah. Mhm. Mhm. Worked backwards. Okay. Anybody else do something different? Anybody else do something different to figure out the period? Yeah, Catherine. P-value as well. And we could take the difference, like the max to the next max, you could multiply by 2, or the difference between the hours multiply by 2. You could see that it is, the period is 8 a.m., okay, which was the 8 hours, all right? So anytime you're doing these types, and I could continue this function, I could keep going, okay? I could keep going because isn't it continuous? It is continuous like a wave. So the period, and what you guys said, all of you actually, as I was going around, all of you came up with very similar ways, just did it differently. Like, Kate, I think you started at 4 a.m. and kind of worked backwards, which was great, which was good. Either way works. Either way is totally fine and acceptable. This just gave you a starting point and just saying the scale is 12 a.m. is 0. We have seen scales like, okay, they give you the period. Here you had to figure it out. Okay? So the period was 8 hours. Therefore, what would your B value be? What would your B value be? 2 pi over 8. What do we got? Pi over 4. Okay, so our equation, and I didn't leave you much room, y equals -6, oops, that side, excellent. Find the depth of the water at 2 p.m. Okay, what would the depth of the water be at 2 a.m.? That's T equals how many hours after 12 a.m.? 14. So Kate, where would I be? 22 feet. How many of you see that and agree? Good. Can't we also, if T equals 14, can we use our equation as well? You could. Okay. At what time after 8 a.m. does the next low tide occur? Yeah, Kaden. 4 p.m. Good. Excellent. Okay. How many times is the water exactly 18 feet tall during the first day? So 12 a.m. to 12 a.m. the next day. Yeah, James? 6 times. Good. Why 6 times? Yep. Good. 6 times. Excellent. How can we find an example? What would you do in this case? What would we do? Tommy, any idea? We would graph it. We would do y1 is our equation. And then y2 would be 18. So we could come up with a variety of examples. But here you would do y1, y2, okay? And then look for the intersection. Okay, then look for the intersection. Okay. Did anyone do that at all? Just curious. All right. Any question? Yeah, David. What is it? What? Say it again. Sorry. 2.93 hours. So if we had this, can we convert this to minutes? I mean, yeah, minutes, seconds, minutes, seconds, minutes. All over the place. Can we convert 0.93 into minutes? Because it's 2 hours. And what? Can't we do 93 over 100 x over 60? Yeah, so jot that down. Yeah. Okay, so 2 hours and 55 minutes and 48 seconds to be exact. Okay, so if you ever wanted to convert, and I'm not saying you will see this, but if you ever wanted to convert 2 minutes, this is what you would do. There was another one, 1.07, which was 1:04 a.m. Okay, there's going to be 6 different times that you could do as an example, but this is what you would do: y1, y2. Okay, questions? And some of you just need a second to digest and look at this word problem again, okay, to see the period is by far the hardest one to figure out. But if you look at it visually and go use the information given to you, you will figure it out. You definitely will. Okay, all of you were almost there, but if you get this part, that's half the battle. The period is the hardest thing to figure out. Okay? Do you guys have any questions? Yep.
Did you know that it was going to be
Cosine. So typically, when you're doing this, we could have, if we started at 4 a.m., it would have been a positive graph, cosine graph, but it's either starting at the minimum or max. It didn't really say that the height at the pier is where the midline is where we're starting. So cosines, we would typically use for our waves, our wave graphs, because you're normally starting at the minimum.
where you don't. Oh, so it says
Only really the fair